Question number 10, a regular question where the idea of electrostatics and kinematics both are involved. Essentially, we study this part under the heading motion of charged particle in electric field. And let's see what is the question all about. There is an electric field given that's in negative y direction. So let's pick up the variable. The electric field has been given and a positive charged particle having specific charge this much is launched with an initial speed. So the value of initial speed is also given. The value may seem scary at the beginning, but as a matter of fact, these values are so beautifully chosen that you would not fall into calculation hassle. And that's the normal characteristic of JEE advanced question. And you could say this particle is launched from here and it aims to hit a target at this point, which is 5 meters away. And based on this, what are the options that we need to choose? We need to first comment on the angle of projection and the time taken from the point of projection till hitting the target. Now let's see, you must have certainly gathered the idea. This concept comes from motion of charged particle in electric field, and the positive charge will be facing acceleration in this direction. If I talk about the magnitude, that is equal to QE by m, and this can be calculated. The specific charge has been given, electric field has been given, so acceleration can easily be calculated. Now, based on this, you could see the motion is going to be a parabolic one, and this would be the representation of the motion. So clearly 5 meter is the range. So with the help of this idea, what I can do is that range is equal to u square sine 2 theta divided by a, that's the acceleration. And you put those values as I have already given, the value of a is known, the value of u is known, the value of range is known, and when you do that, you would be getting sine 2 theta equals to root 3 by 2. That's what you get. And if sine 2 theta is root 3 by 2, it means 2 theta will be equals to 60 degree and 120 degree. We need to take both the options. And what will be the value of theta? The value of theta now will be 30 degree and 60 degree. Let's see if we have. Yes. So option number B, that is the correct one. And then we need to calculate the time taken by the particle, the time of flight. For a given range, there are two angles of projection, what we have already calculated, but for two different trajectories, the time of flight would be different. Okay. So here you could say the time of flight would be 2u sine theta divided by a, which has already been calculated. All those value, you put it, you would be getting the time of flight matching with option number C. Let's go with the next one. The 11th question. This is quite a lovely one, brought from current electricity, and lots of interesting things you'll be getting. There is a semicircular metallic strip that has thickness T and resistivity rho. So let me show it here. The thickness, this side it's there, it's T, resistivity that has been given rho, and let me just keep it here as well. T is the thickness that has been given. And what does the question say? Let's say the inner and outer radius R1 and R2. The voltage that is applied is V0, and that V0 is applied between two ends. So how would the current stream be? That would go in the semicircular manner. That's the applied potential difference V0. Okay, based on that, there is also another factor that the question is indicating. In addition, there is also a transverse voltage delta V, the transverse one, that will be developed between the inner and the outer surfaces. Now this requires a little bit of thought process, and we need to see the value of delta V. So what is the options like? It's something like this. We need to calculate first the value of current, then we need to see that transverse voltage which is developed, whether the outer one is at higher potential or the inner one, that's about BC. And D, the question does not want you to calculate the value of delta V. You need to see that delta V, how is it related to the current which is flowing in the circumferential direction. Let's see. First of all, in order to calculate current, I need to calculate the resistance. So that's the first thing we need to do. And this is a very straightforward one because the current is flowing in this direction. So what we'll do is that I will take a differential element, and the differential element would be in this way, a semicircle of radius. Now how much would be the radius? Let's call that the radius is x. The limit of x will go from R1 to R2. First of all, let's calculate what is the elementary value of resistance. I'm talking of this semicircle. So the resistivity is rho, and length is of course along the direction of the current, and that's pi x divided by the cross sectional area. Now you should imagine as it goes in this way, the cross section area that would be seen here, the thickness is T and this side is dx, so that's going to be T multiplied by dx. But then we need to calculate the total value of resistance, and for that all these identical small differential elements would stand in parallel. So the total value of resistance 1 by R is going to be integral T dx by rho pi x, and of course the limit of x will be from R1 to R2. Get that? Okay, now how much will be the value of resistance? Let's see. To calculate, I can say 1 by R is going to be T by rho pi natural log of R2 by R1, and the resistance will be rho pi by T natural log of R2 by R1. So that's the given value of resistance. Once you calculate the value of resistance, to calculate the current flowing, of course, will be equals to V naught divided by resistance R, and this is straightforward, giving us option number A as the correct one. Okay, so first one has been done. Now the thought process to figure out the potential difference which is developed in the transverse direction. Now you need to think one thing, that if you just further consider the microscopic properties, as the current is flowing, you know, the electrons are moving, and if the electrons are moving, they would essentially be requiring the centripetal force. Now just try to understand, if the electrons are moving, the centripetal force, of course, that has to be directed in this direction, right? So you consider any electron which is moving, so this is the direction of centripetal force. You consider any given electron here. And then the question comes that who is going to provide that centripetal force? Of course, that is going to be provided by the electric field. So it means there has to be an electric field in the radial direction. And where will be the electric field be? That has to be in this direction. Reason being, the charges are negative, so the negative charge would be experiencing force in the direction opposite to that of electric field. And if this is the electric field, now the suspense is over. The inner surface will have higher potential as compared to the outer one. So where is that? The option number C, that is going to be the correct one. The outer surface will be at lower voltage than the inner, or in other words, you can see the inner is at higher potential as compared to the outer one. Okay, now we need to finally comment on the value of delta V. and we need to see how does it depend on current. The delta V, the same transverse one. So the idea is something like this, that delta V, if I talk in terms of magnitude, will be E multiplied by dr, and how much will be the electric field at any distance r. Of course, you can easily see that E multiplied by electric field is going to be equals to mv square by r, the necessary centripetal force. So what I can do that is I can plug the value of E there, which is mv square by E times r dr. Of course, the r will be integrated within its own limit. But then just see, I just need to comment on the relationship of potential difference with the current. And here is that speed, which is the drift speed. And you know, drift speed would be proportional to current. So quite obviously, the potential difference will be proportional to I square. So option number D would also be correct. So for this, you know, the 11th question, option number A, C and D are going to be the correct one. Let's proceed further. The 12th one, that's the final question for this section. Let's see. Question number 12, it's another very beautiful question that centers around kinetic theory of gas, and little bit of viscosity is also involved. Let's see what it says as shown schematically in the figure. So let me show where is the figure. This is the figure, and you could say there are two vessels, and these two vessels are connected by a horizontal tube. Let's go through the question. You know, it says both the vessels contain water solution of potassium permanganate, and the temperature of both the side is T, while the concentration is different. And just see, small n is not the number of mole, that's generally how we represent. This time small n is the number of molecules per unit volume, with N1 greater than N2, and this given condition is there. The concentration per unit volume N1 is much greater than delta N. So this has been given, and they are connected by a tube of small length L having a cross sectional area S. So what I'll do, this is N1, N2, and specifically the temperature on both sides, that's T each, and that's the tube L, the cross sectional area, that's S. Now let's say, apart from that, what does the question say? The collection of the molecules to behave as dilute ideal gases. That means we are allowed to use the ideal gas equation that has been given there. And the difference in their partial pressure causes the diffusion. So whatever is the pressure on the left, pressure on the right, you subtract it, and that differential pressure is the whole cause of diffusion. That's what the question says. And apart from that, there is also one thing. The speed v of molecules is limited by the viscous force. So there is a viscous force acting, and that viscous force, the value is beta times v, if you see, where beta is a constant and v is the speed of molecule. But you need to be very careful. This viscous force is the force on each molecule. It's not in the total, so that may create a mistake. Now, with all these things, we need to calculate, and even the Boltzmann's constant is given. The force causing the molecules to move across the tube is this much. So first of all, we need to comment on the force. So let's say, as per the question, the force is because of the differential pressure, right? So here what I can write is, you know, P equals to number of molecules per unit volume into Boltzmann's constant, temperature in Kelvin. That's what the ideal gas equation says. And this time small n is the number of molecules per unit volume. So we can very properly write capital N by capital V as small n. So it's almost at the breakthrough. You could see the difference in pressure is of course going to be P1 minus of P2. So that's going to be N1 minus N2 into KBT is the difference in pressure. but you need to multiply by S to get the force. And option number A is satisfying. N1 minus N2 is of course denoted by delta N kBT into S. That's the first part. Second part, what does it say? The force balance implies this much. Now you just try to say the speed of the molecule is first of all caused by the difference in pressure, but that would also face a resistance, the viscous force. So at a given speed, the force pushing has to be equals to the force resisting. Now let's see how can we do that, and to understand it we'll do this much. Delta N kB T multiplied by S, that will be the force, and this force should be equal to the viscous force what is experienced. So there we need to understand, I had said beta times V is the force on one molecule. Now we need to go with the entire molecules, which would be having a motion, the total number of molecules contained in this tube. So that's of course equals to N1 SL, because this is number per unit volume multiplied by volume is going to give me the total viscous force. So let's see what happens here. This S gets cancelled with this S, and N1 beta VL will be equals to delta N kBT. So option number B is correct. And then what about option number C? Option number C says the total number of molecules going across the tube per second. That's what we need to see. So how many number of molecules will pass? Let's try to understand that. Per second, okay, that's a main thing that you need to understand. For that, what we will be doing is that N1 is the number of molecules per unit volume, remember. So we need to multiply by the volume so that I'll get the number of molecules and divide by time to see number of molecules crossing per unit time. So let's just consider a small segment right here in the tube, this particular segment. And let's see how many number of molecules would be enclosed there per unit time. That is essentially going to give us the number of molecules flowing per unit time. So we've almost done it. What I can do is that N1 multiplied by V dt into S, this will give me the differential volume of this shaded part, and multiplying by number of molecules per unit volume will give me the number of molecules which are enclosed here. So the passage of this per unit time is what option number C is desiring. So divided by dt is what option number C wants. Now dt gets cancelled there, and the value of V, we have already calculated it for option number B. You put that and you would see option number C to be correct. What about the fourth one? Rate of molecules getting transferred through the tube does not change with time. No, it doesn't seem, because the entire force provider for the molecular diffusion is the differential pressure, and because of the motion the differential pressure will decrease, so of course the speed has to decrease. Therefore option number D would not be the correct one. So for this we have A, B, C as the correct one. Now let's go to section 3.